Okay, this video is going to have us look at how we can use the energy concept numerically to make predictions like how fast, how far, how much energy, that sort of thing. And so we'll use this series of questions which add layers of complexity to the situation that we can analyze. We'll start with a real simple situation here, a cow sitting on top of a hill. So this could be something like this. Here's a hill, and here's the cow sitting up here. We won't do anything fancy for the cow, just a box. And the hill is 10 meters high. So I'm drawing an arbitrary height reference level to be at the bottom of the hill. Well, it makes sense. And so the cow is 10 meters up on the hill. And the question says, how much energy does she store because of her position on the hill? So there's a relationship between the height of an object and how much energy it stores. And when it's up high, it stores energy positionally. And so the relationship looks like this. The amount of energy stored positionally is related to the height, like this, where m is the mass, g is the gravitational field constant, which we've seen before, and h is the height. And so if we use this definition, we find if we put 500 kilograms times the 9.8 newtons per kilogram gravitational field constant times the 10 meters of height, well, you could pause it and do the calculation yourself. Did you get 49,000? And then joules is our unit, 49,000 joules. That's how much energy the cow stores because of her position up on the hill. Okay, so another question that we're going to look at here is how much work was done to get the cow to the top of the hill. And just for the fun of it, let's assume that there's a helicopter lifting the cow up to the top of the hill. So when the helicopter lifts the cow, say the cow starts down here, so then the earth pulls down on the cow, and the helicopter, if we pull up on the cow, force helicopter on cow, and if it's going up at a nice steady pace, those two forces are equal, no acceleration. And that thinking allows us to determine the amount of work done by the helicopter. Now, work done is just energy transferred. But by definition, work is F cosine theta d. Now, what are these quantities? Well, F is the amount of force required. Cosine theta is the angle between the direction of motion, and the direction of the force that's doing the moving. Okay, so that's what theta is. And then d is the distance that it's moved. So let's take a look at this situation of lifting the cow. The amount of force will be whatever the weight of the cow is. That's going to be g times m equals, it was a 9.8 times 500 kilograms equals 4,900 newtons of force. So that's 4,900. Now, theta will be the angle between the direction of the force, which is up, and the direction of motion, which is up. And so that angle is 0, cosine 0. And now the distance the helicopter has to lift the cow is 10 meters. And so the amount of work turns out to be 49,000 joules. And that might not be surprising because since work is energy transferred, then the helicopter transfers this amount of energy to the cow, and as we saw before, the cow then stores that amount of energy as it sits on the hill. Again, energy isn't created or destroyed, just changes where and maybe how it's transferred. In the next segment, we'll look more carefully at that.